Yeah, hello everyone. Today I'm gonna walk you through how I built a smart sunlight monitoring system for my terrarium using an Arduino Nano 33 IoT, a BH1750 light sensor, and Node-RED with MQTT. The system helps track sunlight exposure and sends real-time notifications when the light intensity changes. Before we dive into the setup, let me briefly explain the key components. First is the BH1750 data sensor. It is a digital light sensor that measures brightness in LUX, that is luminescence lux. It's highly accurate and works over I2C, making it easy to integrate with Arduino with the wire library. I use the sensor to detect when my terrarium gets direct sunlight or when it stops. To send real-time updates, I use MQTT, which stands for Message Queuing Telemetry Transport. Uh, MQTT is a lightweight messaging protocol that allows devices to communicate efficiently over the internet. In my project, the Arduino publishes sunlight data directly with the use of an MQTT broker, HiveMQ in this case. It acts as a middleman, ensuring that the publisher data reaches the subscribers. Finally, I also use Node-RED. It is a flow-based programming like tool, which is used to process the MQTT tools, customize some functions in between, and depending on the MQTT topic, it can send alert to my preferred notification method. In this case, it is the email which I have configured. So now on to the setup. Uh, uh, I've uploaded the code and my setup to GitHub. You can check this out on the link ZM722 Terrarium Sunlight Monitor. The hardware requirements are as follows. You need an Arduino Nano BH1750 light sensor, jumper wires breadboard, and a Wi-Fi connection. The pin connections are fairly simple. VCC goes to 3.3 volts for Arduino Nano, ground to ground, and the STA, the data connection to A4 STA on Arduino, and SCL, the clock cycle on A5 as well. On A5, sorry. Uh, this is the code that I've used. You can even see it on my GitHub. Uh, so first we need to start setting up the libraries for Arduino, which are Wi-Fi Nina, Pub Subclient, and BH1750 FVI. Uh, it can be done simply to Arduino ID. You have to go to Sketch, include library, and then manage libraries. So Sketch, include library, manage libraries, and then you can search them and you can install them from here. Next step is setting up the MQTT broker on HiveMQ. So you need to first create an account here, generate your all these credentials, server URL, port, username, password. These are the only ones required in the code, and you have to fill them wherever it is demanded. I've kept pseudo values here, but you can replace them with the actual values. And then after setting up the HiveMQ details, we need to set up Node-RED as well. First, we need to install all the libraries. Install Node-RED, the Node-RED, Node MQTT, Node-RED, Node email, and then we create a flow as follows. So first, a MQTT which subscribes to the topic of terrarium/sunlight. Uh, Once this is done, we need a function that will, you can customize this as per your requirements. This decides what the email subject will be and what the payload inside the email, that is the data that we send inside the email, will be. And it will simply forward us to the notification mechanism that we connect to this function. So in my case, it's email. We need to fill in our email and password and uh, follow the steps here to ensure that our email gets connected. Once that is done, we just need to start the Arduino Nano 33 IoT. As per our connections, the setup looks as follows. Yeah, if we ensure like we connect the pins as per the setup given, that is VCC 3.3V ground STA A4 and SCL to A5, it will sort of look like this. And once we have this setup working, we can start our code. Also on the web client on HiveMQ, we need to generate a username and password. Then we can start a program which will sort of generate output like this. This is my CLI output. And once our code starts running, we'll start seeing output like light intensities the sensor starts detecting. And the light intensity, the sensor will start detecting. And if it crosses a certain threshold that I was fixed in my code, we say sunlight started. If it goes back, we say sunlight stop. So in this case, my threshold was 1000. So when it reached 1420, we said sunlight started. And then we said sunlight stopped when it went back below the threshold. You'll receive emails as per your configuration when you complete this task. And the output on the node red should show that on the SMTP, using the SMTP protocol, the message was sent to your email ID and it verifies whether what you've done is correct or not.